All right, so this is Mastering Chemistry, Solids, Liquids, Intermolecular Forces, question number 11. Just a quick update on how to do it. So the question's talking about how much energy, or how many kilojoules per se, to convert 115 grams of ice at 0 degrees Celsius to liquid state at 32 degrees Celsius. It gives us a heat of fusion of 334 joules per gram, and it gives us our specific heat of liquid water as 4.184 joules per gram degree Celsius. So every time I tackle one of these questions, I draw our heating curve, right? And so we have our solid, we have our phase change, we have our liquid heating up, we have a phase change, and then we have our gas heating up. And remember, each phase change is either our boiling point or our melting freezing point. So I went ahead and I gave us our temperature in degrees Celsius here. So water freezes or melts at 0 degrees Celsius and it boils at 100 degrees Celsius. So what I do is I say, all right, we have ice, which is the solid state of water at 0 degrees Celsius. So 0 degrees Celsius is this line. And remember that this section here is solid. So that's why I'm going to start right here. This is my starting point. That is ice at 0 degrees Celsius. And then it says to liquid at 32 degrees Celsius. So 32 degrees Celsius is between 0 and 100. So I just put it on our chart. It's probably a little lower, but that's where I'm putting it. All right, so now we have to figure out what equation is the plateau or the phase change, and what equation is when we're heating up our liquid. So we have to do a total of 2 equations to get from point A to point B. This first section here is Q equals MHF, and this second here, and the second area here, it's Q equals MC delta T of our liquid state. I'm sorry about that. All right, so now we have to do some work. So Q equals MHF, so mass is 115 grams times the HF value, which is 334 joules per gram. Notice grams, and then this one's a per gram, so those are going to cancel out. We'll be left with joules. So we need to multiply that. Give me 1 second. All right, sorry, I had to go grab my calculator. So it's 38410. All right, if I look at sig figs, we're looking at 3 sig figs. So 38400, and this is in joules. All right, and then the other one is our Q equals MC delta T, and this is of the liquid. So the mass, again, is still 115 grams, times the specific heat of liquid water, which is joules per gram degree Celsius, times the change in temperature. So the change in temperature up here, this mark was 32 degrees Celsius. And down here, this line is 0 degrees Celsius. So the difference is between 32 and 0 degrees Celsius, which is 32. So we're going to hit equals. We're going to type that in our calculator. So 115 times 4.184 times 32. And I got this value of 15397.12 joules on my calculator. And I'm going to round that to, let's see, I think they did 32.0. I'm not sure if they did 32.0 or not. So let's just round it to 3 sig figs, 15400 joules. And what we're supposed to do with these values here, our values here, we need to add them. All right, so we have our 38400 plus 15400 joules equals, and then we're going to have 00 joules, and 8. So we have 53,800 joules. But the question asked for kilojoules. So we have to remember that 1,000 joules equals 1 kilojoule. So we need to take this value here, this new answer here, and divide by 1,000. So 53.8 kilojoules is our final answer. All right. And there you have all of my work.